Wi-Fi Sheep would like to say a huge thank you to all of you that kindly support us. Help us continue to bring new videos like this. Join patreon.com/Wi-Fi Sheep from just $1 a month. Hello everybody and a very warm welcome back to youtube.com/Wi-Fi Sheep with me, Tom. And this, which is February the 1st, 2025. It's a Saturday and I'm taking a day off from my normal live streaming 8 till late program, which we normally do live every Saturday evening. If you're not up to speed and don't know what we're doing with the series, we're currently up to episode 7 at the moment, and episode 6 and 7 of series 3 that you can go and watch back right now, and I'll put links in the descriptions of this video. We have been working on renewing and restoring a couple of my Acorn BBC Master System 128s. Because I want to move things along with the live stream series and need to get these machines ready for this year's exhibition season, I thought I'll just do this video just to tie a few loose ends up and show you kind of where we are with renewing the 128s, as well as getting a few things up and running, so when we get back to the live stream next week we can kind of move on and do other things that we need to do in the series. So on my desk, and excuse the wide angle and the slightly distorted lines, it is just the fisheye look that the overhead camera does. So this is an original Acorn BBC Master 128. It's 128 because it's 128K of RAM on one of these. They are still 6502 8-bit derivative. They're still completely BBC Micro compatible. But the Master System, as it's more commonly known, added things like a slightly different keyboard layout, including a numeric pad. We also had slots for the first time for cartridges, and the case was slightly redesigned. And if you ask me, even more ugly than the Model Bs, the more common Model Bs. If I take the lid off, I'll show you where we got to inside. So, unlike the stock Model B, the BBC Masters have a CMOS and need battery backup. One of the problems I was having was the batteries failing and we losing all the machine's setup settings. Originally, when Acorn released these machines in 1986, there's meant to be a lithium cell that sat here. Unfortunately, that lithium cell had some kind of fault and caught fire. Acorn's replacement idea was to put in basically a sealed polythene bag containing 3 Duracell branded AA batteries. I actually have one of the originals here. They literally soldered these together. They don't even have a cover, and they simply put a diode and a resistor onto the original cable to stop these non-rechargeable batteries from being recharged by the machine. Obviously these power cells go bad and do tend to leak. Luckily, unlike later Acorn machines, the leakage rarely gets on the main PCBs and is mostly contained by the polythene wrap that Acorn used. Last time I used this pre-made battery holder. We put 3 fresh Duracells in and we connected up. Fortunately for this machine, and this wasn't my doing, which way round the connector goes is actually written inside the case. I also had to find out all the fixtures and fittings. The story of this particular Master 128 was I've had it for a good few years, and this one I've never actually used, and it never actually been powered up. So we attempted to power it up live on the stream. The power supplies for both BBC Micro and Master Systems, the switching supplies, generally are filled with reefer capacitors. And I have a couple here which I've extracted. And reefers generally have a tendency to short out, crack and explode. They're commonly found in a number of 80s and early 90s power supplies, including those for things like the early Apple Macintosh, in our case the BBC Micro, but they're also found in things like Apple IIs and other products. So it's worth checking to see if you actually have reefer branded caps, and if you do, they need to be replaced. What we found with this particular power supply was it didn't actually have reefers in. It must have been a later Acorn machine where they switched to a polymer-based cap, which doesn't need to be replaced. Admittedly, all the capacitors in here probably do need replacing now, as they're going to be getting on 40 years old. But for now, we ran with this supply because we could say the supply definitely wasn't going to explode and it was working fine. So in this video right now, I've got the machine wired up. I've just off camera here got a SCART to HD and HDMI converter. We're running from a RGB DIN type connector to a SCART plug, and we'll connect that through to my capture card. So you should be able to see in perfect crystal clear digital quality the video output of this machine. The rest of the machine is completely stock. Now right now I want to see if it's remembered the CMOS settings from when we set it up on the live stream. So this is what I'm seeing as well. So let's power up. And that's looking good. So it's gone through to the Acorn 1770 DFS. That's the disk filing system. It's loaded basic and it's sitting in basic. If I type help, if I type star and help, the keyboard is a little grubby and needs a clean. There we can see what we've got. So the OS version is 3.20. The DFS version is 2.24. The sideways RAM or SRAM is 1.04. And we have the advanced or ADFS version 1.50. So that's the stock ROMs you'd expect to see on the system. If we now go star ST dot, this is short for status, this will tell us how the machine was set up. The last time I set it up, these settings have to be done manually with the star.co. or configure command. And we can also ask it what ROMs it has in the system. And you can see the ROMs that state unplugged basically are ones that aren't being initialized in the system. And you can actually see from ROM 0 to ROM 8, there's nothing there at the moment and they're all unplugged. So that's fine, that works absolutely fine. And that's what I would expect from a BBC Master 128. Right, so I'm just going to power down from the main switch on the back and that's fine. Now I really just need to make sure that we've got all the screws in, and I need to find a way to fix this battery pack from just rolling around in the machine. Acorn didn't fix anything in. They literally just... Acorn didn't actually fix anything. Acorn didn't actually fix anything in. They literally just shoved their polythene bag of batteries, wedged it under the keyboard. I kind of want to do something a little bit better than that. So I think for now, I've got some double-sided tape, and we might just try and stick down some double-sided if we can. So take that out. We've got some original adhesive pads, so this has clearly been used. These battery connectors are not stock, they are aftermarket. I haven't done the setup on this. In fact, I can't remember if this actually came in this machine or not. But what we'll do is I'm just going to put down a couple of lines of double-sided. And I'm not saying it's a perfect solution, but if the battery box isn't floating around, it means it can't come into contact with anything. It also means it can't disconnect itself, meaning the machine loses all its settings. If a BBC Master 128 loses all its settings, it is a complete pain, because basically the machine doesn't really boot up particularly well, and it doesn't boot to basic or any kind of command structure you can actually do anything with. And it's just tediously annoying. And that's no good, especially when I want to take these machines out on exhibition and show this year. So we do need to try and make sure we get this sorted. So there we go. Okay. So let's see. And actually, you can actually see there's actually been, I didn't notice this before, there's been a little bit of corrosion on there. So it looks like a battery has actually leaked in here at some point. That's not ideal. I think we'll leave that for the time being, because I think it'll be all right. Clearly, even in this packet, a battery leaked. But if it leaks either on itself or destroys the battery pack, that's fine. What we don't want it doing is obviously leaking on the motherboard. So we'll just pop this and just get the battery pack. Okay, that's quite secure. So that will be okay there. I can still get access to the battery, so that's great. Now the screws aren't quite right. So this one I kind of wedged in on the live stream isn't the right screw, and also the PSU isn't actually screwed in underneath. So that's something we probably need to do before we do anything else. I'm just thinking, I was going to say let's put the body shell or the top back on it, but no, let's not do that. So let's grab ourselves a suitable screwdriver. Because this screw here is absolutely not the correct one to go in there. These screws are needed because it needs to earth or ground, I think it's earthing actually, between the metal of the keyboard and the metal on the back of the machine with the PSU. So it's just to earth it all together. So it is kind of important those go on. When I dismantled these machines, and I don't remember doing it, it was such a long time ago, I did keep all the bits in a plastic box because I was thinking, where are all the fixings for these machines? There's nothing worse than taking something to bits and then having no idea what you did with any of the fixings. I believe from memory these darker screws are actually the ones that go into the PSU. This longer screw, there we are, might actually be the one that needs to fit in there. And I do have a couple of nylon washers as well, so let's just see if this longer screw will go in here. And it will. That's great. We might need to just take some of the plugs out the back of the machine. I've also got a few things connected in the front, which isn't ideal. And I'm just going to hold the power supply where I can. Put a washer. Actually, the washers go in there. See if I can get the power supply screwed in. Ooh. We don't want to over tighten things, but we do want to make sure obviously that our power supply isn't about to fall out the machine. So okay, I am missing one screw fixing for this, but that's not a disaster at the moment. At least the PSU is now safely in. So let's carefully flip the machine over. You can see actually I've got a floppy drive and also a mouse in the user port underneath. So let's just, and rather annoyingly, my battery packs have moved. So that is not sticking down as well as I'd hoped. There are now better solutions for this, but this is what I've got at the moment. Anyway, right. So that's now down. Let's go back to capture. Let's just make sure we are still working. Of course, it does help if I actually do put the video lead back in. Let's try that again. Okay, so let's just... Oh, actually, I've just put the video lead in the wrong port because I can't see. There we go. There we go. And it's good to see that that's actually working okay. And it's remembered the settings, so we're all good. Control break. Excellent. Right, now the keyboard on this computer, despite the rest of it being quite clean, the keyboard is really, really mucky. It's sort of a dirty, stuck dust that you can feel when you actually type on it. So for now, what I've got is these surface wipes. These are just like kitchen, bathroom type surface wipes. And just as a sort of semi-quick solution, we'll just take, never ever get one wipe out. It always ends up being about 5. Right, as a semi-quick solution, yes, I've pulled out 2 at once. Right, semi-quick solution, and we'll just obviously make sure we power down the machine. That always helps. I'm just going to give this keyboard a very quick clean. Ideally, what I really want to do is take all the keys off and clean them individually, which I might still do. But if we can just clean the keys up so you don't feel like you're touching dirt every time you press a key, That would help enormously, and it will obviously help just with the cosmetic appearance of this machine. And you can kind of see the dirt that's coming off. Okay, it's not going to win Keyboard of the Year award by any stretch of the imagination, and I do need to do a bit more work with it, but at least the keyboard is now cleaner so that the actual letters are white and not a sort of off shade of brown. So that's made an improvement, and it actually feels a bit better to type on. As far as I'm aware, all the keys are actually working okay. Remember, this keyboard actually isn't that old in the kind of scheme of things. These computers were still being manufactured up until 1993, and they were still on sale in 94, although the very last 90s batch switched to a different key style, a cherry key style. I forget what the keys on these are, but this is a proper key switch keyboard. On the BBC Micros, it always was a proper key switch mechanical board, as opposed to the later and cheaper membrane keyboards that some 8-bit systems used or reverted to. Okay, so we just zoomed in slightly closer angles so you can have a slightly better look at the PCB layout. Now, this machine I do want to try and keep relatively stock if I can. Again, I'm just paranoid my batteries are going to fly out, but everything else is now fixed in. And things like the cradle, if you like, for the speaker and what was the battery, and the slots for the ROM cartridges is just a friction fit, and that's actually fitted in correctly. At least I think it's a friction fit, yes. And the screws that hold the PCBs, ironically, are either side of the cartridge slots. Now, on the BBC Micro, and in this case the BBC Master, you have a series of EEPROMs which are down the side of the machine. The BBC Model Bs had basic operating system and a disk filing system as separate EEPROMs. The Master System incorporated all that and more into a single EEPROM chip. So for your system to function, you do need to have the stock Acorn EEPROM fitted in your Master. You can have all the other slots empty. And I always say with people with the Acorn machines, the way you installed drivers on these machines, or new bits of hardware for drivers, was with a screwdriver and physically slotting EEPROMs into the slots here. Now, the later BBC Micros, including this, the 128, had the ability to use Shadow RAM or Shadow ROM. And that was, I believe, this chip or this chip, I forget which one it was. But there are two jumpers. There's a jumper here, labelled as LK19, and there's one just hiding here, which is labelled, I think it's LK12. If these two are thrown into the left-hand position, which these two are, because I've set them manually, and it's just a little plastic jumper that you pull out and set, it will deactivate these physical ROMs and switch it into, and I believe it's this chip, or it might be this one, but it's one of the chips here, and that actually allows for software loading of ROM or EEPROM images, meaning you don't physically need the chip. It does mean in some cases, and some later software took advantage of this, that it can actually load additional soft drivers into the machine, and you don't need the physical EEPROMs. It's not permanent, and it only works whilst the machine is actually up and running. The data isn't retained once the machine is turned off or power cycled. Another addition, which I have pinched off my other machine to put onto this one, is this little adapter board. This, which I've got the wrong way around, is actually a BBC Master Raspberry Pi adapter, and it slots on the internal slots in the machine like so. And again, we just have to be careful just to make sure we get the pins lined up. There we go. This one I'd soldered the pin header on myself, and I did it a few years ago with the wrong type of flux. So on one of our recent live streams, I believe it was episode 6 of series 3, I actually went and had to resolder a lot of this because we'd started to get corrosion on the pins. That was my fault because I'd accidentally used the wrong type. I used plumber's flux, which was a mistake, when I've now in modern days switched to an alcohol-based electronics flux. So this is what I now use, which is much better. Also means you don't have to wash that off. I didn't wash off the flux originally, and that's why we had corrosion, so I had to rework this board. Now this board is for the Raspberry Pi Tube Direct, In the case of the 128, it allows you to run internal coprocessors, which are emulated using a stock Raspberry Pi with the emulators and the code loaded onto micro SD card. There's a 32 gig card in this Pi. This is a Raspberry Pi A+, so it's with the original chip. It's not particularly powerful. It's 512 megabytes of RAM on board, 700 megahertz clock speed, but it's perfect for what we need to do to act as a virtual co-processor for our original BBC Micro hardware. In this case, the board just sits upside down and plugs straight into this pin header, like so, and that's all neatly contained under the machine. Let's cut back to our capture and let's power it back up. All looking good. So that's the stock boot for a BBC Master 128. And you can see there it says Acorn MOS, Acorn 1770 DFS, that's the disk filing system, and BASIC is loaded, and that is stock BBC BASIC, so commands like CLS work perfectly fine. However, if I now go control break, you'll now notice it says Acorn Tube 6502 and 64K. So we are now running with a virtual second processor, which this means the Raspberry Pi is working. The interface that that card taps into is called the tube interface, and you can see it now reads as 6502 64K. We can on the fly talk to the Raspberry Pi and change that interface. So if I go star and FX, so it's a star FX command, and I call it by going 151, 230, comma, and then I can set a number of different parameters that I want. So if I go 8 and hit return, nothing happens. If I go control break, you'll now see that the text at the top of the screen has changed, and we're now running as an 8286 with nearly a whole 1 megabyte of RAM, 869K on board. This alone has now changed our machine from a stock 128 into a virtual, what was known as a BBC Master 512. The 512 had an Intel coprocessor and was able to run some IBM and DOS based software. Now, spoiler alert, I have actually been playing with some floppy disks for the first time in 2025 the other day. And we had a little bit of an accident. But for now, I have here my box of Maxwell 3.5 inch floppies. And I do have the boot discs for a DOS operating system, in this case GEM from Digital Research. The first disc is in ADFS Acorn format. The second disc is in straight FAT32 DOS format. I have here a modified Amiga 3.5 inch floppy, and it's actually waiting for a drive. I modified this from the Amiga interface to the BBC interface, which is stock 34 pin. I'm going to put this disc into the drive, and it's waiting for a disc. So if I put this disc in, you'll notice it's switched to Acorn ADFS. So let's just shift break that again. Okay, so now we're at the star prompt. If I go DOS boot, there we go. You'll have seen this on the channel before, but we can actually load Digital Research DOS, not MS, not Microsoft DOS, but DR DOS. And we're loading a bootstrap loader, and this is a custom version of DOS. This is PC x86 DOS for the BBC Master. It effectively turns our machine into a virtual IBM compatible PC running a 286 processor. And there we are, A drive. Of course, we've only got A drives to play with. Now, this is where things get a little bit interesting, and unfortunately it's entirely my own fault, I believe. So I take the disk out. Now we've now switched from ADFS, we've now loaded as DOS. So any future disk that goes in the machine is now PC compatible. So if I put in the second disk, let's switch back to the interface, and I can simply do a dir command, and that'll tell me the directories on the disk. There we go. And it should be able to load Gem Desktop. And I should be able to do that by typing gem. Unfortunately, that now doesn't work because I now get a syntax error because there is now a problem with assign.system, which means we go straight back to the A prompt and can't load Gem Desktop. So I need to do some kind of repair to this disk, which I can't do straight on this machine. This is extremely annoying, and it means I'm going to need to boot one of my bridge machines with a working 3.5-inch floppy drive in order to make some adjustments to see if we can actually get the desktop back up. So at the moment we are a little bit stuck. I am, however, pleased to say that what does work and doesn't need the graphical user interface is on this disk here. Now, I've shown this before. I use it as my stock go-to. But if we go back to our screen, if we now look at this one, again, this is just a normal DOS formatted disk. HeliSim will actually work. So we should be able to say cd HeliSim. And you can see there a .exe, so we should be able to just load heli. And you'll see the BBC Master is capable of running the resolution and also the colours of the PC CGA mode. It's also interesting to note that we have now gone from an 8-bit machine, 6502 based 8-bit machine, to a 16-bit Intel x86 based machine. All this software is Intel PC DOS 16-bit. Now, if I go to my menu by hitting escape, this works, by the way, exactly the same on a full-blown IBM PC or IBM compatible. We go to mode, put it in demo mode, which I like to do. It's my favourite mode to do. You can actually see it runs relatively well. Yes, it's a bit slow, but it does run relatively well considering the speed of the machine. This was designed originally for the original 80, it's either 80086 or 80080, I forget which chip it was. But basically, we're now running in 286 mode. The original Master 512 came with the original Intel chip. So it didn't come with the 286 as standard. So in virtual emulator mode, bearing in mind a Raspberry Pi is doing a lot of the heavy lifting here, we actually get slightly better frame rates, slightly better speeds. And yeah, it's slow, obviously, but that's not bad. That's native PC software, in this case Sierra's HeliSim, a game running on the BBC Master 128. Okay, I'm going to show you one last thing before we need to go and fix that broken gem disk, which I think might be a whole separate video. I want to show you something that uses the shadow or side RAM that we've enabled in the Master 128, but first we need to turn off the coprocessor. To do that, we can simply call a command. So I've hit break, we've gone back to the star, you can see it there. We're actually in a high resolution mode at the moment, but we can go FX and we say 151, 3 or 230, sorry, comma, and now we want to turn off the processor, which is number 14. If I go number 14 and hit break, the processor, the CoPro, has now been turned off. So we're now back to stock configuration, and there we are back in 8-bit mode. Now, a few years ago now, but in recent times, BitShifters did a port of Stunt Car Racer to the BBC Micro, and I have an old Amiga magazine disc that I've recopied or repurposed. This is a double density floppy, and I've repurposed it for Stunt Car Racer. It works in stock DFS mode, so that in that case it's the Acorn 1770 DFS, which we have here as stock on the machine. Now if I go star C dot or cat, we should be able to have a look at, this is all in Acorn format, there is the disk. And if I go shift break, we should be able to load this game. Now this game, or port of it by bit shifters, only works because we have the extra EEPROM memory space, because it has to load into that space as well as filling up the RAM of the machine. So this doesn't work, for example, on a stock Model B without additional side memory or side ROM. So S and D, I can't play this very well, but I'll just show you it for an example. So yeah, okay, but it's actually a very, very good port. Single player, name, Tom. I'm just going to do a practice. Practice the drawbridge. There is the drawbridge. And we can actually turn the angles around so we could look at it from all 4 angles. It's actually a really good port. I remind you, this was not... Oh, I'm going backwards. I'm going backwards. There we are. I remind you, this is not native to the BBC Micro. It's a... Oh, I need to actually turn the corner. There we go. It's only been ported in recent times, and I believe it's from the Commodore 64 code. I don't know what is happening. So that's how it's running, basically. The Commodore 64 version. Just going to go very slowly. Commodore 64 version, of course, native 6502, the same as the BBC Micro, hence why the code was portable. But it does need the extra RAM and the extra memory space. I mean, I assume it's the C64, it might be from the C128, which explains why it may actually only work on a 128 BBC Micro. Oh. It's a fun game if you know what you're doing. Oh. Bang. But you get the idea. So this machine seems to be working really well. The overall condition of it is very good. Let's get my discs out. There we go. So the case is in good nick. Probably just needs a wipe down, but the case is very, very clean. The keyboard, until I've cleaned it now, it's much better, but it was very mucky as well. So this is one of 2 BBC Master 128s that I want ready for this year. And this one I'm thinking may have the co-processor fitted permanently, and maybe my Gem PC machine. The other one, perhaps not having the co-pro, but my other machine has the Video NULA graphics enhanced chip fitted, and so it can do higher resolution modes and better color graphics. And I may run that either with an emulated floppy drive, so things like the Gocart, or I may run it with the TurboMMC SD card filing solution that fits underneath the machine. You can't run TurboMMC SD card filers because they sit in the same user slot that you need for a mouse or pointing device, so hence why on this machine we're back to using floppy disks. Okay, so for me what I need to do now is figure out why I managed, or how I managed to brick the version of Gem that's been running fine for a couple of years. I've done other videos, I've shown Gem running on the BBC Master before, so it's just a little bit annoying that I've managed to brick the system. Admittedly, any kind of point and click graphical user interface is always a pain to use if you have to shuffle using a single floppy drive. Early Macintosh users had pretty much the same issue. So I do have ideas afoot as to how to make this a bit more usable and enjoyable experience, and also expand the amount of software that we could potentially run on the BBC Master. However, I can't do that if I bricked the operating system in the first place. So that's coming up in a new video shortly, hopefully, when I can figure out how to repair whatever it is I did that broke things in the first place. Don't forget, I will be back very shortly with 8 Till Late, our live stream. It happens normally every Saturday at 2000 hours GMT. We're currently on season 3. It'll be episode 8 next week from time of recording. If you haven't done so already, please do consider liking and subscribing, and keep across Wi-Fi Sheep across social media. Search at Wi-Fi Sheep. I will have some show dates of exhibitions and shows that I intend to be at this year. I've at least got 2, possibly 3 happening for 2025. Really excited about that. Again, be really excited to meet you, and also be great to get these machines. I want to get my Acorn collection of vintage computers out on show for you to have a look at and play with in person. As always, thanks so much for your company. Don't forget to like and subscribe, and I'll see you real soon right here on the channel. Until next time, bye for now.